It should be 9 carbons. Now, you could have chosen these two methyl groups up here to go along. You would get the same thing. You'll get the same answer. But notice it's a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. If you do any other possible continuous chain, you'll get less than 9. So 9 is the longest. So now what you have is, notice you have 3 substituents. You have a methyl here, and you have an ethyl. So let's start numbering. Number from the side closest to the nearest substituent. Notice in this case, what do you notice? There's a tie. All right, 1, 2, 3 substituent, or 1, 2, 3 substituent. So what side do you start on? You start on the side closest to the substituent that alphabetically comes first. Now we go to alphabetical order. So we have an ethyl, this is a methyl, and this is a methyl. So ethyl comes before methyl, so we're going to start counting on this side right here. This is number 1, this is 2, 3, 4, 5, 6, 7, 8, 9. Okay? Again, the rule is if you have a tie on either side, you start on the side where the substituent alphabetically comes before the other one. If those are tied, then you go to the next substituent. All right? And then whichever next substituent is lowest number, or alphabetically is first, that's the one that you do. Okay, so let's go on. Notice we have 2 methyl groups. So what happens if you have 2 of the same group? Okay, well, what you use is the generic prefixes that everyone has learned in all their other classes. All right, if you have more than one, if you have 2 or more, if you have 2, you have to use di in front of the name. If you have 3, tri. If you have 4, tetra, not quatra. A lot of people put quatra. Don't put quatra. It's tetra. 5 is penta. 6 is hexa. Hepta. Octa. Nona. And deca for 10. Alright, you kind of have to memorize these. Now, these are not used alphabetically when you name them. Not used alphabetically. Okay, again, just another rule. There's a lot of rules. Alright, so when you name the methyl group, you don't alphabetize the di part of it in comparison to the ethyl. You compare the methyl part of it to the ethyl. Okay, so why don't you put this on pause? I'll put it on pause, and you can go ahead and practice and write out the name of the molecule. All right, so let's come back. You've got an ethyl group and you've got a methyl group. Ethyl is alphabetically first, so it's on the 3rd carbon. So it's 3 ethyl. All right, hyphen. Now you have the 2 methyl groups. Now notice the methyl group, one of the methyl groups is on carbon 4, the other methyl group is on carbon 7. So you have to tell the reader where both methyl groups are. So it's 4, 7 hyphen dimethyl. That's how you name it. Okay, so just to repeat it, you have methyls on carbon 4 and a methyl on carbon 7. Since you have 2 of them, use the word di. If you had 3 of them, let's say you had a 3rd one on carbon 5, you would have 4, 5, 7 trimethyl. Okay, and remember, the D is not used alphabetically. The M is still used alphabetically. And then you name the parent, which is non, and since it's an alkane, it's nonane. Okay, so 3 ethyl, go over it again. 3, because the ethyl group alphabetically is first, it's on the 3rd carbon. You got your 2 methyls, one of them is on carbon 4, the other one is on carbon 7. So it's 4, 7. Commas are between numbers. Hyphens are between numbers and letters. Dimethyl nonane. Okay? The other thing I want to talk about is if you don't have an alkyl substituent, what happens if you have a halogen? I can quickly go over this. So let's say you have a halogen substituent. All right, so let's say you have, I don't know, CH3, CH2, CCl, H C, CH3, H, CH2, CH3. Okay, so longest continuous chain is 6 carbons. It's not hard. I don't make this hard. I just want to show you what to do when you have a chloro. Your substituents, you have a chlorine and you have a methyl group. Start on the side closest to the nearest substituent. Notice in this case it's 1, 2, 3 on that side, or 1, 2, 3 on this side. I have a tie, so what do? Alphabetical. Which group is alphabetically first? The chlorine. So I'm going to start counting on the left side. 1, 2, 3, 4, 5, 6. Substituents, you just name the first, halogens, you just name the first part and then end it in O. So for example, fluorine would be a fluoro group. Okay? Chlorine would be a chloro group. Bromine is bromo. Iodine is iodo. So this would be called 3-chloro, 4-methyl hexane. All right, now we're going to talk about different isomers. So isomers of alkyl groups. So what happens if our substituent is an isomer of some alkyl groups that we've learned? And the ones we're going to learn about is propyl and butyl. Okay, so let me just kind of show you an example. Let's say you have CH3, CH2, CH, CH2, CH2, CH3. Sorry about that. I had to think about the molecule I was trying to draw. All right, so here's our molecule. Okay. This actually is not going to work. Sorry about that. Let's erase this. Even while recording, you still have errors. So I'm going to pause this and I'm going to come back with a molecule. All right, I'm back. I'm sorry about that. Okay, so here we have a molecule. All right, longest continuous chain is 1, 2, 3, 4, 5, 6, 7. So that is your longest continuous chain right there. This happens to be in a straight line. If you hook it as well, so if you go like 1, 2, 3, 4, 5, 6, 7, that will also be a chain, and then this will be a substituent. It'll be the same compound. The name of it will be the same. That's usually what happens. Then here's my substituent. Okay? So number it on the side closest to the nearest substituent. In this case, it doesn't matter where you name it. It's going to be equal either case. 4, 5, 6, 7. Okay, so this is called 4-propyl heptane. Okay, nothing fancy. There isn't anything new here. All right, we've learned this. What I want to get at is this propyl group. I can draw a different isomer of this propyl group. Rather than having the carbons continuous like this, so carbon hooked to another carbon, hooked to another carbon, I can have a different isomer. I can have a group where it looks like I have a CH and a CH3 on one side and a CH3 on the other. And I can have that hooked onto the chain. Okay? So let me draw this molecule and show you what the difference is. So it would be a CH3. So this is almost identical to the other molecule, CH. But instead of the carbons continuously being hooked to each other, you have it hooked to the second carbon of the propyl group. Okay? Make sure you notice the difference. Okay? Notice this time your carbon is bonded to the carbon in the middle of the propyl group of the substituent, rather than the carbon being hooked to the first carbon of the chain. That's what the difference is. That's why it's an isomer of that alkyl group. So this is still our substituent. This is still our longest continuous chain. Okay, but this has a different name. This group is called isopropyl. Okay, and you have to be able to recognize when you have a carbon that is hooked, that when your longest chain is hooked to the central carbon, or if the carbon is hooked to the first carbon. It's not that hard, but you have to be able to recognize that. And when you name this, you name it isopropyl. And in this case, the I is used alphabetically. How I remember it is alphabetical. Okay, the word is in the name. There's a lot of is's in there. Okay, so iso is used alphabetically. So you don't use the P, you use the I. So the name of this compound would be 4-isopropyl. What would we say? Heptane? 4, 5, 6, 7. Yeah, heptane. Okay. So this substituent is a propyl group, but it's an isomer of a N-propyl. Remember we talked about N-propyl, the carbons in a straight chain? Okay. So this is called isopropyl. Now, we have the same thing for butyl, but butyl has 3 other isomers. Okay, butyl, remember, is 4 carbons. So it's a 4-carbon substituent. You still have the butyl group. So I'm not going to draw a real molecule. I'm going to just kind of make an imaginary molecule. So imagine this is my longest continuous chain. It's not important what it is. I just want to show you what these 3 other isomers are. Okay. First of all, a butyl group would be if you have these 4 carbons in a straight chain. I just want to show you the difference between them. You have to be able to recognize the difference. So imagine that this is my longest continuous chain of carbons, and this group happened to be a substituent. There's 4 carbons in a row. That is called butyl. Okay? Now, I can have different isomers. I can have this hooked to the second carbon of the chain. So it would look like this. You'd have a CH3, your carbon here. Sorry about that. And then a CH2 and a CH3. So this time your longest continuous chain is hooked to the second carbon of your butyl chain. That is called sec-butyl, because it's hooked to the second carbon. I think that's why they call it sec-butyl. Okay, and let me throw in some more confusion. Sec is not used alphabetically. You still use the B. Just remember, iso is. Everything else is not. Okay, so if you remember that, you'll always have it right. So that's a sec-butyl group where you have a carbon attached to another carbon, which also is attached to the longest continuous chain and is attached to the 2 other carbons. Okay, I'm going to make this chain a little bit longer because we have 2 other groups that we have to get on there. I want to have plenty of room. The next one looks like this, where this is hooked to a CH2 group, and that CH2 is attached to the other 3 carbons. So notice this is a different isomer of a butyl group hanging off of your continuous chain. This is called isobutyl. Alright, and remember we said iso is used alphabetically, so you use the I in this case. And that's what isobutyl looks like. You have a CH2, then you have the other 3. Notice these are 4 carbons in a row. 1, 2, 3, 4. This is, you also have 4 continuous carbons, but the main chain is hooked to carbon 2. In this case, you only have 2 consecutive carbons, and then you have these 2 hanging off of it. So that's what an isobutyl looks like. Finally, the third one is called tert-butyl, and this one I think is pretty easy to recognize. It's a carbon, it's a quaternary carbon with 3 methyl groups hanging off of it, and that's called either T-butyl, you can call it T-butyl, that's what some people call it, or you can call it tert-butyl. And the B is used alphabetically, not the T. So for sec and tert, they're not used alphabetically. You just use the butyl, and the iso is used alphabetically. Okay, this does confuse people. I usually spend a lot more time in class on this. If you are so confused, I'll have no trouble going over it again in class. Read the book. The book, I think they do an okay job at trying to explain the difference between all these. Otherwise, we can go over it in class. And that is the end of section 2.3.